Hello, everyone, and thank you for joining this last session of the day. Today, as mentioned, we're going to talk about how we can use the HashiCorp Cloud Platform to help us implement Zero Trust. Now, what I like to do with a lot of my talks is just to make it really resonate with people, and how to do that is to tell a good story. So I'm going to tell you a story, which is a true story. So buckle up, get your popcorn ready, get your drinks ready, and we shall get into this. So, you can see on the screen, there's a gentleman named Keiju. Keiju is a mathematician whiz, right? He was a quant for a quant research company based in London, right? Now, shortly after he joined this company, there was a bonus round. You know, a lot of us have performance-related bonuses. He hadn't been there that long, so his expectations for what he would get paid as a bonus wasn't very high. But he came up with a figure of £3,000, right? That's what they paid him. He wasn't very happy with that, but bear in mind, he hasn't been at the company that long. So this motivated him to try and figure out how could he increase his bonus the next time a performance-related bonus round was there. So he immediately began working on something that they call signals. So in the quant world, signals are just trading strategies that are computed in an automated fashion, so they can execute these trades without people having to do the things manually, right? So he was working on these signals. The hope was he was going to impress his bosses, right? He would impress them so that when the next bonus round came up, he would be able to get a much higher amount. So in working on these signals, he would obviously work during his working hours. He would also work evenings, weekends. He put his all into this. And in total, between when he was paid the £3,000 and the next bonus round, he came up with a total of 20 signals, right? So 20 signals. So what happens with these signals is they will run simulations, they will run tests, and all sorts of things there to figure out which of these signals, if any, are good enough to be used in the trading platform, right? So after all these simulations, there were a total of 7 of these signals. That's 7 out of the 20 that were adopted by the hedge fund. So, you know, 7 out of 20, it's a pretty good return in terms of all the work he had done. You know, you're never going to get everything adopted, but 7 out of 20, he had high hopes for what his bonus would be. So the figure that he came out with for what he would like for his bonus was £1.1 million. I repeat, £1.1 million. That's what Keiju wanted as his bonus, right? So the next bonus round comes along, and it turns out he wasn't awarded £1.1 million as a bonus. In fact, he was awarded £400,000, right? Which, you know, to a lot of us is a lot of money, but there's a big difference between £400,000 and £1.1 million. So clearly, Keiju was very disappointed in this, right? So he decided he no longer wants to work at this quant research company. He is going to begin planning his exit, right? So he began looking for jobs. So he's actually from Asia, so he started looking for jobs back in Asia. And this is where the story gets interesting, is he began accessing secretly the signals of his colleagues, okay? The main issue he had with accessing these signals is the way that his employer stored these signals was they would scramble them. So rather than a complete signal being stored as one deployable unit, if you like, they would scramble them and store them in different places, right? So that was the biggest challenge when he was accessing his colleagues' signals, right? Now, they do this obviously to prevent the signals being copied by the quants, and also just ways for them to protect their intellectual property. So, you know, he needed a way to get around that if he's actually going to access these signals. So he built a decompiler program, right? So he spent many months from this point onwards copying signals and decompiling them. He did a lot of this whilst working remotely from his flat in East London, whilst he would be doing his day job and whatever social activity he was doing on the side, right? And he managed to secure 2 job offers while he was doing this. So he spent months copying these things, decompiling them, whilst he was speaking to other companies about potentially joining them. Now, the thinking is, if you have these signals, you have very valuable intellectual property, and that will make you an attractive proposition to other hedge funds out there who might be interested in your signals. So I think that's what his thinking was with this, right? So he secured 2 job offers back in Asia while doing this. Now, during this time, Keiju also got married, right? So it was a small affair. His parents came over from China to London to witness the ceremony, as his girlfriend's parents did. They had a ceremony, and when his parents were returning to China, he gave them the computers that he used to copy and decompile these trading signals, right? So they took him back to China, so he didn't have them anymore. He's obviously had this honeymoon period, and he's gone back to work as normal. So he's worked the normal day and waited for everyone else to leave. And when they've left, he's cleared his desk. And the last thing he did was he left a resignation letter on his manager's desk. So all of this is going on. His employers had no idea that he was looking for work elsewhere. They had no idea that he was secretly accessing and stealing intellectual property. Right? They had no idea about any of these things. So his employers found it quite suspicious, the sudden nature of his departure, right? You know, they've come into the office the next day, his manager's seen the resignation letter on his desk and figured, what is going on here? So they enacted certain protocols. So they checked the CCTV camera footage. They began to look at system access logs and try to figure out when he was logged in, exactly what he was doing when he was logged in, you know, all the different things that they have in place for this, right? And this is when they realized what Keiju had done. This is when they realized that he had stolen their intellectual property. Now, by the time they realized this, Keiju was already in the plane at 30,000 feet on his way back to China. So his employers contacted a really large law firm in London and asked them to help mitigate the situation. This law firm then contacted some private investigators in China. So by the time Keiju had landed, there were already private investigators on the ground waiting to confront him. Yeah. So we're going to fast forward a little bit, right? Keiju didn't want to go through the whole extradition thing, so he agreed to come back to London. Essentially, he was tried in a British court, he was convicted in a British court, and he was sentenced to prison time. Now, why am I telling you this story here? Right? There's a moral of this story, and the moral is Keiju was an employee. He was already inside their network. He was already in their systems. And the moral of the story is you have to assume the attacker has already breached your systems, right? This could be malicious, like in this case, in Keiju, he was stealing intellectual property, or it could just be a human error that causes an issue, right? Either way, we're going to need to put systems in place to protect ourselves from these threat actors and from ourselves. So now I've told you that really interesting true story that should be a Netflix special. Allow me to formally introduce myself. My name is Rob Barnes. I'm a senior developer advocate at HashiCorp. I'm primarily focused on the secure product line. I'm also the co-host of the Keeping It Secure podcast. I don't know if any of you in this room are listening to it, but look out for HashiCast. I'm one of the co-hosts there. My main interests are in lowering the barrier to entry for developers when it comes to security and removing passwords from workloads, just to increase our security posture. And a lot of the things we talk about on the podcast, a lot of the things we discuss in talks like this is around trying to make these things more possible. Now, the title of this talk is implementing Zero Trust with HashiCorp Cloud Platform. Well, what exactly is Zero Trust? You know, it's a common thing that probably a lot of companies are using to increase their SEO. But for me, the first time I came across the term Zero Trust was Google's BeyondCorp initiative, right? So far as I know, and I'm happy to be corrected here, Google may have invented the term zero trust, right? Now, this Beyond Corp initiative understood that the way that we were doing things before was problematic. This castle and moat approach that Armand talked about in his keynote this morning, where we had a perimeter which is very rigid and we trusted everything inside it, that was high trust, and we deemed everything outside that to be dangerous. Well, Beyond Corp realized that that approach wasn't very scalable. It didn't work with this new multi-cloud paradigm that we were moving into. And there were, challenges with trying to get their employees to be able to connect and work remotely from different locations, like hotel Wi-Fi's or internet cafes, so on and so forth, right? So they realized with this initiative that the approach had to change, right? And this is when they started to flip the script a little bit. So instead of trusting everything that's inside the network, in fact, we're not going to trust it, right? We're going to take a different approach. And just like in the Keiju story, we're going to assume that our systems have already been breached, right? So if someone's already inside your system and they can access everything, then that's not very good. If you can start to verify who someone is and what they're able to do and what they're not able to do, then you can begin to wrestle back a degree of control over how secure your systems are, right? So zero trust is taking a different approach to how we used to run things before. When we think about the way we used to assign identity, back in the day, we would, give IP addresses to machines. And that machine would run a specific part of our application or whatever. And essentially, that IP address represents an identity. And I know it's crazy to think that, but we did that for so many years. The problem with that is it's not scalable now because we're moving to the realms where IP addressing is more dynamic, even ports are dynamic. We can't guarantee that this IP address is going to represent this service. So we need other ways to assign identity. And Beyond Corp understood that. So they began implementing their own ways of managing zero trust. So we go back to the story. Assume that the attacker is already in there, right? So we trust nothing at all. We trust nothing, we trust nobody. And we have to verify everything. So that means before any action can be performed, we need to establish two things. The first thing we need to establish is who or what is trying to perform this action. And secondly, are they authorized to perform this action? So how can we go about doing that? How can we, figure out the identity of someone, and how can we figure out if they're allowed to do something? Well, the core construct here is identity. We heard Armand talk about this again in his opening keynote, and I'm echoing this to the fullest because it's so true. Identity is the core construct to zero trust, right? And this is something we want to centralize. Identity can be a person, it can be a machine, it can be an application. Whatever it is, verifying identity is about authentication, or as we call it, auth-n, right? We do this by providing a piece of unique information to that principle. So if we think about us as humans, how do we authenticate as humans? Well, that unique piece of information is more than likely going to be a password, something that only we know. It could be for your banking card, your credit card, it could be a PIN. In the case of an application, it's probably going to be something along the lines of an X509 certificate, something that is unique to that principle, right? So once we've verified the identity, we can then verify the authorization to perform the actions, right? So let's look at this in a practical example. So here we have a very, very simplistic representation of an application. I'm pretty sure the people in this room are dealing with application stacks that are far more complex than this. But for the sake of just illustrating this, we'll just go with the simplistic view. So we have the client side of our application. So typically this is what our customers, this is what our target users will use to interact with our applications. We then have the server side. So that contains all of the business logic, all the application logic. That's the layer where the magic is happening. And then we have the data layer. So this can contain things like your customer data, your application data, maybe personally identifiable information, whatever it is, right? This is all the data that your application needs to perform its function, right? But when we talk about the business value of an application, in a lot of organizations' case, we are talking about the data layer. The data that is contained within the application is the value of the business, right? It's the thing that they need to protect. Now, this doesn't mean that the other layers of the application are not important and we don't need to protect them. But if we think about it in the context of this example, these are merely attack surfaces to get to the real prize, right? And in this case, this is going to be the data, right? So, what are the threats to our application data? We have, firstly, we need to protect the confidentiality of our sensitive data, right? So we mentioned PII, or personally identifiable information, other customer data, even sensitive data, things like our customer passwords and so on and so forth, right? We need to protect the confidentiality of these things. And how we go about doing that is we start with a data classification strategy, right? So if we watch the movies, you see spy movies, they'll see something like this is top secret or highly classified, or whatever it is. This is kind of the military way of looking at our data and saying this is something that's highly classified, this is things that are eyes only, and actually this piece of information isn't so sensitive, right? We can think of that as a data classification strategy. Now, we don't all have to adopt a military approach. We have to do something that represents our business structure, our business posture. So we're not going to copy these things out of the box, but you need to figure out what your organization deems as sensitive and what it needs to protect, right? Once you know these things, it starts to inform your decision-making about how you go about protecting these things, right? Next, we need to protect the availability of our data, right? So it's all good that we've protected the confidentiality of it, but it's no good if our applications and or our customers or anyone that is authorized to access this data cannot access it when they need to, right? If we think about some of the most famous data breaches, or not even data breaches, just attacks that have happened to organizations in recent years, a lot of them haven't actually attacked the data directly. What they've done is they've attacked the availability of the data. So if you look at things like denial of service attacks, or DDoS as we tend to call it, these things prevent our systems from operating correctly. They prevent us from accessing our application data, which ultimately brings down our systems and applications, right? So a lot of people tend to forget this part of the security realm, but we need to protect the availability of our data. Next, we have integrity, right? So, like I said, we've protected the confidentiality of it. Our data is available when we need it, but that data isn't worth anything if we can't trust the integrity of it. I can give you a practical example of that. If a banking data says that in my application there is £1,000, right? But then a malicious threat actor can manipulate that data unauthorized to say that, no, actually, I don't have £1,000 in my account, I have £1 million in my account. We can no longer trust the integrity of the data, right? So we need to protect those things there. So if we look at the confidentiality, the availability, and the integrity of our data, these are what we call the 3 pillars of cyber security. Now, if you look at the way that I've formed this image here, this diagram, I've done it deliberately in the shape of a house, right? I think if I weren't working in software, I'd probably work in architecture because I really love buildings, and there's a lot of similarities between building houses and building software, right? So I've built this sort of to look like a house. And if you think about a house, what the core value of a house is to keep a roof over our head, right? We say this in England. We say, well, as long as we have a roof over our head, that's the real value of a house. So if we translate that to our application stack, we have our data, and that's the roof over our head. That's where the real value is. keeping our roof over our head is why we have a house. Then we have those 3 pillars, which we talked about in cybersecurity. So if we go back to our house analogy, these are our bricks and mortar. These are our walls. These are the things that hold up our roof. These are the things that are holding up our real value, right? In this case, our data. But you can't just build walls just from here. You have to dig foundations for these things, right? Otherwise, the walls will fall down. We just have to realize that if any of these pillars are compromised, then our roof may fail. So going back to our analogy, we may have data problems or compromises if any of these pillars fail, right? Then we think about the role of zero trust in there. So zero trust is kind of like the foundations for these pillars, right? Like I said, you can't just build walls, you have to dig foundations, you have to pour the concrete, something solid as a base for these things to be built on. So when you put this all together, what do you have? You have a nice, solidly built house, right? Which should not fall. But that's what insurance policies are for, just in case it does. Now, we mentioned zero trust, and we have to assume that the breach has already happened. We mentioned that we must trust nothing, and we also mentioned that we must verify everything. So, how do we do this in practice? Well, in order to verify everything, like we said before, the core building block is identity. And with identity, we can drive access controls, right? So this primarily can be split into 4 areas, right? This is a very similar diagram to what Armon had in his keynote this morning. So we're going to run through these principles here. So the first thing is machine authentication. And that's concerned with how do we prove a machine's identity? How do we manage what a machine is authorized to do, right? So if you think about our applications in the stack, if they need to talk to other applications or other APIs or so on and so forth, how does our applications prove who they are, what they are, and that they're authorized to do certain actions, right? Next, we have machine-to-machine communication. So this is more at the network layer, but this is concerned with which machines or which services or applications are allowed to communicate with one another, right? So if we think about the difference between this and the machine authentication, the machine authentication was about proving identity, well, this is about communication. This is almost like a firewall saying which things can speak to which things cannot speak to which things, right? So when we think about an entire application stack, not all parts of your application should be able to access a database. The chances are there's only certain parts which need to be able to read and write from a database. So when we think about machine-to-machine access, it's about governing that kind of that flow of information and communication. Next, we have human-to-machine access, right? So when we think about the whole machine-to-machine access, now we're thinking about, as a human, how do I connect to a machine, right? When things go wrong, sometimes we're going to have to connect to a machine to identify the issue, troubleshoot the issue, and resolve the issue. But in order to do that, we're going to need to be able to connect to that machine, right? So how do we know that we've connected? What do we do when we were connected to this machine? You know, all of these things play into this zero trust model. And then the final part is human authentication. So if you think about how this whole thing started, we started with machines and we've gone full cycle to humans, but the problem, in a way, is the same. Just much like machines, how do we prove our identity? How do I prove that I am Rob Barnes? How do I prove that I'm Rob Barnes? I have access to do these things, right? And those are the 4 areas that we need to tackle when we talk about zero trust. And essentially what we need to do is, because it can be such a complex thing to implement, we need to try and centralize things as much as possible. So if you think about HashiCorp Cloud Platform, there are 3 tools on there that can help us implement zero trust, right? So when we talk about a machine authentication and authorization, that's concerned with Vault. Again, Armon did a fantastic job in the keynote explaining the business value of Vault, how we can use it to broker identities on behalf of platforms for our applications, right? Now, if anyone has tried to set up Vault and manage that by themselves, you will realize there is a big operational overhead with that, right? So the goal here is, we want the business value. We want our applications to be secure, but we don't want the overhead of supporting the things that are going to make it secure, right? So with HashiCorp Cloud Platform, you just, with a few lines of code, can deploy your own Vault cluster, and from there, you can build your zero trust foundations, right? So that will take care of your machine authentication and authorization. Next, we have Consul. So Consul is also available on the HashiCorp Cloud Platform. Now, with Consul, there's a really, really neat feature inside there, which we call Consul intentions. With Consul intentions, it allows you to specify very granularly which services are allowed to communicate with which services, and also the flow and direction of that communication, right? So when we think about machine-to-machine access, now we mentioned that was at the network layer, and we're talking about communication here. With this type of granular control, we can start to increase the security posture of our application stack. And then we have the human-to-machine access piece. Now, the human-to-machine access piece, as we mentioned, generally speaking, we probably won't need to access production components until something goes wrong. But when something does go wrong, how do I, from my laptop, working from home, access this database, which seems to have failures on it? How do I do that? Now, in a lot of people's world, the way they will do that is maybe using a VPN or something like that. Now, the challenge with a VPN is, typically speaking, the way a lot of companies have set it up is, once I'm able to create that secure tunnel between my network at home and the corporate network, once I'm in, then we've gone back to our castle and moat approach, right? I'm now a trusted entity, and I have access to everything, even the things that I should not have access to, right? Because even though the system says I'm authorized to do that, I don't actually need to access things to perform my role. So when we think about the role that Boundary is playing, well, what Boundary is doing, it is creating a proxy from my machine directly to that target piece of infrastructure. So in this example, we're talking about a database. So instead of me having access to all of the corporate applications and infrastructure components, I have access to this database because that is what I am authorized to do. Now, we talked about why you would want to use HCP or HashiCorp Cloud Platform to do something like this, and it's quite simple, is you want to be up and running as quickly as possible. You need a quick return on investment, and you don't want the support overhead. When I sit there thinking about my years as a consultant, one of the biggest challenges we had with Vault was we've deployed Vault, people are using it, everything is good, but then when a new version comes out, how do we upgrade to the new version of Vault? How do we manage that? We have to think about patching the operating system layer. All these things add to the attack surface of any platform, any application. We need to manage all of these things, right? And there are entire teams sometimes that are employed just to do these things. It adds, support overhead. It can add complexity to your organizational structures, right? So having Vault managed for me, where all I have to do is think about my identity and access management strategy, all I have to do is think about how I can plug in my existing identity provider, because like we say, identity is the core building block for zero trust. It doesn't make sense to have to replicate these things across different things. We want to use our centralized identity platform, right? And all we have to do is plug it into Vault. We don't have to worry about spinning it up or managing the lifecycle of it. We think about Consul, the same thing, right? These things are really powerful tools, really powerful platforms, and with power comes complexity, right? No one wants to manage this upgrade cycle. No one wants to manage the infrastructure underneath that if they don't have to, right? There are some use cases where people have to, but in general, if you don't have to, you probably choose not to. And we also have Boundary, right? Boundary, the same thing. If anyone has tried to set up Boundary in a production-grade manner, you will see there are a lot of steps involved, and that's just setting it up, and then we've got the same process of managing the lifecycle of that as the years go on. So how can we get up and running really quickly? Well, the nice thing is, we happen to be HashiCorp, and we have this cool thing. You might have heard of it. It's called Terraform. And in Terraform, we have a HashiCorp Cloud Platform provider, right? Which is nice. I think a lot of us are probably used to describing our infrastructure in Terraform. We just express ourselves with that. And Terraform takes care of interacting with the target APIs, and it just gives us our infrastructure. So it's very declarative, right? In the same way, instead of just giving us a piece of infrastructure, we can turn around and say with Terraform, I'm going to need these pieces of the HashiCorp Cloud Platform to implement my zero trust strategy, right? So let's have a look at a practical example of that. In this case, we have a very minimal, very minimal example of deploying Boundary to your HashiCorp Cloud Platform account, right? There isn't much involved in it. You want to give it a cluster ID name, and you want to give yourself a username and a password to do your initial login. Does it? These few lines of code, that gives you Boundary. It's as simple as that. But when you compare that to having to, firstly, get the infrastructure, imagine you're on bare metal. You have this whole month-long or a few months-long procurement cycle. Then you have to install your operating system. Then you have to do all these other things that you have to add on just to meet your company's compliance. And this is before you even get to the value of why you even got this thing, right? Which is to install Boundary. But here, we've just got a few lines of code. It will probably take you about 10 minutes to stand up, just running that, and you are good to go. We'll look at another example. This is Vault. Again, give it a cluster ID, right? What do you want to call this cluster? What HashiCorp virtual network do you want to deploy this cluster on? When we think about how our clouds work, we tend to have VPCs in AWS or VNets or whatever the networking construct is in your cloud provider, or in HashiCorp Cloud Platform. It's the same thing. We have HashiCorp virtual networks, right? So we can just tell with Terraform which HVN that we want to deploy this on, and which tier we'd like to deploy. We have different tiers depending on your organization size and your needs, right? But again, the point is, in just a few lines of code, you have Vault. You know, it's amazing. I haven't even had to cut this down. And finally, Consul. Same thing. You get the pattern. Cluster ID, HVN, and the tier, right? Those three pieces of information, Terraform, apply, dash auto approve, because we don't really run plans these days, do we? And you have the core building blocks to start thinking about how to implement your zero trust strategy. Now, the thing that's nice about this is, you know, once you've got these building blocks in place, you're still going to need to configure Vault to operate the way you need it to operate for your organization and application platform, right? You're still going to need to configure Consul with things like intentions, and you're still going to have to configure Boundary with all of your targets, and you need to bring in your identity providers and so on and so forth. But this is why it's amazing to be able to deploy these things with Terraform, is because Terraform has this thing called the Terraform registry. If you use Terraform, you've probably used this before. It's the thing that houses all of the Terraform providers, but it also houses Terraform modules. I myself am author of, I think, around about 17 Terraform modules, which are mostly security focused. And the nice thing about that is it means that we've got our building blocks in place, but I don't have to do the hard work of authoring my own Terraform code to deploy our identity and access management strategy with these tools. Someone else like myself has probably already done the hard work, and we can leverage the hard work of others to deploy our strategies, right? So, you know, I have modules for Boundary to get you up and running, to get your targets in place. You can use things like Consul Terraform Sync. I have modules for that where it will just look at your Consul services and it will automatically keep your Boundary targets up to date. But that's the thing, you can crowdsource all of this configuration from other people. What you're doing is just applying it values that work for your organization, right? So when we think about HashiCorp Cloud Platform and the value it brings, well, it's kind of like your time to market. When we think about if we didn't have a cloud offering, and it's funny, I always had the idea of HashiCorp Cloud Platform when I was a consultant. I always said, if I'm going to start a business, I'm probably going to start something just like this. I guess HashiCorp beat me to that idea. But that's the point, is no one wants to do these things, and there's a lot of complexity involved in doing these things. There's a lot of organizational challenges that you have to get over before you even get to the people, the processes, and the technology, right? So that's the value of this, is we can use all of these tools together. They integrate very nicely. You can leverage the work of other people to implement these things here, and you can increase the posture of your organization and your application stack. And with that, I'd like to thank you very much. I hope you've learned a lot about how we can use HCP to implement these things. And if you have any questions, I will be outside, happy to talk to anyone. Thank you.